China is about to change the game in orbit again. With plans confirmed, China will launch new modules to the Tiangong space station, expanding its size, power, and global role. This move answers rising demands for scientific capacity and international collaboration, just as the ISS approaches retirement. From advanced docking hubs to global astronaut training, Tiangong is evolving fast, and it's not just about science. It's about influence, leadership, and the future of space itself. China is officially preparing the next phase of expansion for its Tiangong space station, responding to rising scientific demands and positioning itself for broader international collaboration. The announcement came via Wang Zhu, a senior official at China Aerospace Science and Technology Corporation, CSC, who confirmed that the powerful Long March 5B rocket will be used for future launches of additional modules. These upgrades mark a significant evolution of the station, which was initially assembled between 2021 and 2022 as a 3-module T-shaped orbital outpost. While no exact timeline has been disclosed, this expansion is clearly driven by the increasing volume and complexity of space-based experiments, which are pushing the limits of Tiangong's current capacity in both physical space and energy supply. A key part of this plan is the deployment of a multifunctional expansion module. This module is designed with 6 docking ports and will connect to the core Tianhe module, laying the groundwork for future modular growth. This modularity is central to China's approach. Not only does it enhance Tiangong's ability to host new scientific payloads, but it also improves the station's long-term viability. The expansion is expected to provide China with greater flexibility to support crewed missions, advanced experiments, and potential international collaborations. Crucially, this is not a new idea. Chinese officials have floated the possibility of expanding Tiangong for several years. But the recent confirmation indicates these plans are now entering an execution phase. The new modules would effectively transform Tiangong into a larger, more robust platform, capable of supporting sustained activity in low Earth orbit for years to come. This effort comes at a time when the international space landscape is shifting. With the International Space Station approaching its decommissioning and NASA's budget for ISS operations facing cuts, China is preparing to fill a vacuum. The upcoming expansion positions Tiangong not just as a national asset, but as a potential international hub for science, exploration, and diplomacy in space. As China looks ahead to Tiangong's expansion, it's also taking significant steps to boost both scientific capacity and mission safety. Among the most anticipated developments is the launch of the Xuntian Space Telescope, slated to ride aboard a future Long March 5B rocket. Xuntian represents China's bold entry into deep space observational science. With a 2-meter aperture and a 2.5 gigapixel camera, it is designed to survey vast areas of the sky, with a field of view nearly 300 times larger than the Hubble Space Telescope. Xuntian will co-orbit with Tiangong and is engineered for periodic docking with the station. This feature allows for upgrades, maintenance, and refueling, enhancing the telescope's longevity and adaptability over its planned 10-year mission. It will play a key role in studying dark matter, dark energy, galaxy formation, and the broader evolution of the cosmos. Alongside this scientific leap, CSC is addressing a major concern: the safety and reliability of the Long March 5B rocket. Previous launches of the rocket drew international criticism due to the uncontrolled re-entries of its first stages. Wang Zhu stated that efforts are underway to redesign the first stage for safer, controlled re-entries. Additionally, China is working to increase the overall stability and maturity of the Long March 5B system to ensure mission success and reduce risk. The rocket has recently been used to support China's ambitious Guowang satellite constellation, where its upper stage, Yuanjing 2, has been employed to deliver payloads to precise orbits while keeping first-stage impacts away from populated areas. These improvements indicate a growing maturity in China's launch capabilities, aimed at sustaining a long-term presence in orbit. Beyond Tiangong and Xuntian, the nation is also developing a new generation spacecraft for both LEO and lunar missions. The low Earth orbit version will be partially reusable and capable of carrying up to 6 to 7 astronauts or reduced crew and up to 500 kilograms of cargo. The lunar variant, named MESO, shares a common booster core and is expected to support China's crewed moon mission before 2030. Tiangong's planned upgrades are not just about hardware. They're part of a broader geopolitical and diplomatic strategy. With the International Space Station nearing the end of its operational life and uncertainty surrounding the pace of commercial replacements, China is leveraging Tiangong to become a leading platform for orbital cooperation. One of the most groundbreaking moves involves China's announcement to train astronauts from Pakistan. This would mark the first time foreign astronauts travel to Tiangong and signals a new phase of international engagement for China's space program. Discussions are also underway with other countries to expand this participation, making Tiangong a viable destination for nations historically excluded from major space projects. Expanding the station with new modules not only adds physical capacity, but it opens the door to more frequent and diverse crewed missions. These international missions are expected to be shorter than China's current 6-month stays aboard Tiangong and will likely involve targeted objectives and shared research priorities. To support this shift, China is building out its transport architecture. The new generation LEO spacecraft will enhance mission flexibility, and by 2026, the Long March 10th rocket will begin launching these vehicles into orbit. The modularity of Tiangong, combined with new crew vehicles, gives China the infrastructure to handle parallel national and international missions. The strategic timing is important. As the ISS faces structural aging and reduced U.S. funding, China is offering an alternative. Rather than wait for uncertain commercial solutions, countries may choose to align with China's stable and expanding orbital program. In doing so, Beijing gains not just prestige, but long-term influence over how science is conducted in low Earth orbit. The Tiangong expansion isn't simply about adding space, it's about projecting leadership. By combining modern hardware, flexible launch platforms, and diplomatic invitations, China is laying the foundation for what could become the world's most active crewed space laboratory. China's decision to launch new modules to the Tiangong space station is far more than a technical upgrade. It's a declaration of intent. As global space leadership shifts and the ISS nears its end, Tiangong is rising as a fully operational, modular, and internationally open platform. With enhanced scientific capabilities, new crewed vehicles, and the inclusion of foreign astronauts, China is laying the groundwork for a long-term presence in low Earth orbit. The message is clear. China isn't just participating in space, it's preparing to lead it. What we're witnessing is not the next chapter of Tiangong, but the beginning of a new era in space exploration, one that may soon orbit around Beijing as much as Houston. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries, and don't forget to leave a comment below. Also, you can visit our website, spaceinews.com. Thank you for watching, and see you next time.